All right, in module number 2, lesson number 3 of SISAS, we're going to talk about Cisco ISE Authentication. Quite a few things that we'll be talking about in this particular chapter. Obviously, authentication is the first step in the process of bringing devices onto the network and authorizing them for a specific type of access. We know that we can do authentication on ISE, but there are a couple of different ways that we can do it. We can do simple authentication. We can do rules-based authentication policies. So in this lesson, we're going to talk about the differences between those and how to configure different authentication on the ISE platform. We're going to talk about authentication, policy elements that are included in the authentication process. What is an authentication policy? What is it comprised of? We'll take a look at some examples. We'll look at rules-based authentication, different authentication conditions, how to implement rules-based authentication on the ISE platform, how to configure simple authentication conditions, how to create and tune compound conditions, and then define what's allowed as far as a protocol goes. How do we create and tune different authentication rules? And then how can we tune or configure or modify the default authentication rule? And then we'll take a look at, wrapping up the lesson, Cisco Network Access Manager. We'll take a look at network groups and the Cisco Network Access Manager. And then finally, wrap up by looking at network settings in the Cisco Access Network Manager piece. So quite a few things that we'll be talking about in this particular lesson here. Now, as far as ISE goes, ISE is a policy-based network access control solution. We know that. It offers network access, guest access, posturing, client provisioning, profiling services, and so on. All the things that we talked about in the previous lesson. When we're configuring ISE, we have to create authentication policies. That's what this lesson focuses on. We'll take a look at authorization policies next, guest configurations, postures, profiling policies, and so on. Policy conditions are really the building blocks of everything that we do within the ISE platform. And there are basically two types of policy conditions. We have simple policy conditions and we have compound policy conditions. So let's talk a little bit about the difference between simple and compound before we get into this, looking at this flow chart and kind of identifying what we're looking at in this particular flow chart. We use a rule-based policy to provide access, profiling, posture assessment, and guest services. These rules-based policies consist of rules that are made up of specific types of conditions. Cisco ISE allows us to create conditions as individual conditions, reusable policy elements, and then we can refer those from other rule-based policies as well. A simple condition is just basically an operand, or what we call an attribute, an operator, which is equal to, not equal to, greater than, and so on, and then some sort of value. So we can save simple conditions and we can use them as part of our rules-based policy. And in this lesson, we'll take a look at some examples of what those particular simple conditions look like. And, so let's say, for example, I have A operand B, all right? A happens to be the attribute from the ISE dictionary. We'll see what the dictionary looks like a little bit later on. B can be some sort of value that the attribute A can take. And then the device type is, maybe an attribute for network devices that could include things like value, which could be A equals B or something to that effect. Compound conditions are made up of multiple simple conditions that are connected with an and or an or operator. All right, so compound conditions are actually a derivative of a combination of multiple simple conditions. And we can save and reuse different compound conditions and other rules-based policies if need be. So I can say, for example, X operand Y and A operand B and X operand Z, etc., etc. So again, we'll see some examples of these conditions as we go through the configuration here. Typically, policies are going to consist of different rules. In this particular case, we're talking about an authentication policy, right? That's this box here that represents the rules that we have tied to that particular policy. Each rule is going to consist of a set of conditions that need to be satisfied to allow a specific action to be performed, like maybe somebody gaining access to network resources and so on. Rule-based conditions really form the basis of the policies that we're configuring in ISE, and it sets the rules that are going to be used in the evaluation process. During policy condition evaluation, ISE compares an attribute with whatever particular value was presented. So it's possible that where an attribute is specified in the policy condition, we may not have a value assigned in the particular request. That would be like example, a not equal to, and then the condition that it's going to evaluate will be set to true in that particular case. So we're going to take a look at how to create these simple conditions by going to policies. Then you go under policy elements and conditions, and you can specify an authentication policy condition, an authorization policy condition, a guest condition, and so on. And then we can add that as a simple condition. Or we can create compound conditions by, again, going to policy and policy elements and conditions, and then specify compound conditions. There are different types of conditions, profiler conditions, and so on, but we're going to focus primarily on authentication to start with, all right? So we would use the ISE admin portal, and we can define, in this case, authentication policies that determine who accesses the resources on the network and what they can do. Now, authentication policies are defined based on the protocols that ISE uses to communicate with the network devices and the identity sources that it uses for the authentication process, if that makes sense. So identity sources could be internal databases, it could be externally identifiable sources, and so on. And then we have these different authentication conditions. We will have essentially two different major components in an authentication policy: network access service or identity source. Now, if we talk about network access service, that's going to consist of, what are the allowed protocol services, the protocols that are handled based on the initial request, and then the protocol negotiation, a proxy service that will proxy requests to like an external radius server for processing. And that's what they're showing us here in the case of this external identity source. That will be that external process that's being applied, right? This whole lesson is about this gray box right here. We're going to have another box about authorization, and then we have a profiler service, guest services, and posture services, which I mentioned previously, okay? After you install ISE, a default identity authentication policy does become available that's used for basic authentication. We can either update that policy and override the default settings, or we can create our own policies in the system itself. During the policy condition evaluation process, Cisco ISE is going to compare the attributes with each value. Now, it is possible to run into a situation where the attributes specified in the policy condition may not have a value assigned in the request. As I mentioned before, that's going to be an operator that is used in comparison to not equal to, and then that's going to return again a condition of true. All other conditions would be false. For example, the calling station ID is not equal to some value or whatever. There are multiple protocols that we can define within our authentication policy. We can do password authentication protocol, protected extensible authentication protocol, PEEP, MS CHAP v2, which is the Microsoft Challenge Handshake Authentication Protocol, EAP MD5, EAP for a message digest, EAP TLS, EAP FAST, and then PEEP TLS. All right. And as far as the authentication type, it's going to be based on the protocols that are chosen, right? The authentication type and the protocols can be supported by lots and lots of different types of database. The authentication type is typically going to be password-based, where authentication is performed against a database with a username and a password that's presented in the particular request. The identity method, which basically is the result of the authentication policy, Could be deny access, which is basically access the user is denied because no authentication is being performed. Identity databases, where we have internal users, guest users, internal endpoints, Active Directory users, LDAP database, Radius, token server using like RSA or a safe word or something like that, or certificate authentication profiles based on PKI. And then we also have identity source sequences, which is a sequence of identified databases that's used for the actual authentication. If we choose the identity method as deny access, obviously in that particular case, a reject message is going to be sent in response to whatever the request was. If we choose an identity database like Radius or whatever, an identity source sequence, and if that authentication succeeds, we're going to continue on to the authorization policy. And that's what they're depicting with this little arrow right here, right? After I've checked my authentication source, verified it against different authentication conditions, the result could either mean that we're going to deny, or we're going to send the process down to the authorization step, which we'll talk about in the next lesson. Okay. So obviously there's some different kinds of conditions that can occur here, right? Based on what we're seeing. Now, if we want to talk about authentication failures, there are basically three different types of authentication failures that you're going to see within ISE. The authentication failed, the user's not found, or the process failed. All right, this is a little bit more than what this slide is depicting, but I think it's important to have this complete picture when we're talking about the authentication policy. Authentication failed means that I basically received an explicit response that the authentication failed because of a disabled user, bad credentials, for whatever reason, right? And then the default course of action in this particular case is to go ahead and reject the authentication. Another option you might see is user not found, right? No such users found in the identity database. In this case, also the default action is going to be reject the user. And then the process failed. All right, now process failed means unable to access basically the database, the external database source. In this case, the default action would be to drop the authentication as opposed to reject it. All right. Of course, you'd have to then go and start troubleshooting and trying to identify why that failure took place. Cisco ISE actually allows you to configure lots and lots of options based on failures. You can send a reject message. You can do a drop, which means that no response is sent, or you can do a continue, and that's what that arrow represents. A continue means let's go ahead and move on down to the authorization policy. So the result of this box here could either be a reject, a drop, or a continue. Reject or drop means you don't leave this space, and a continue means that you move down to the authorization piece. All right, even if you choose the continue option, there might be instances where Cisco ISE can't continue processing the request because of restrictions on the protocol that might be used. All right, it is possible to continue the process even if authentication fails. Maybe you have an authorization policy, you're doing MAC authentication bypass, or you're shifting to a different authentication method, and so on. All right. For all the authentication protocols, when authentication fails, we can reject the request that was being sent. If the user is not found or the host is not found, we can reject the response that's being sent. And if the process fails, then we can just simply drop the request. All right. Now, there are a couple of things that I want to point out here based on terms and things that you might need to know for the test. We have this, I've already mentioned a couple of these terms, right? We have allowed protocols, we have identity source, and we have failover options. The first one is really just the set of protocols. The allowed protocols is the set of protocols that ISE can use to communicate with the device that's actually going through the authentication process and trying to authenticate network resources. Identity source defines the database that ISE is actually using for the user's information. We see that in the two middle boxes here. Database could be an internal database, or it can be an external identity source like Active Directory or LDAP. We can actually go into ISE, and we'll see this configuration a little bit later on, and we can add a sequence of databases to an identity source sequence and then list that sequence as the identity source within our policy. So what's going to happen is ISE is then going to search the credentials in the order that the database was listed in that particular sequence. So it doesn't have to just be an individual source. It can be multiple sources that we process in a sequence. Then we have failover options as well. We can define what action ISE is going to take if authentication fails, if the user is not found, or if for some reason the process fails, right? We talked about those three possibilities based on reject, drop, or continue. And so those are some terms that you would definitely need to be aware of, okay? All right, so I kind of alluded to some of the policy elements that are included in this process. I mentioned a couple of these terms, right? The policy elements for ISE include authentication, authorization, profiling, posture, client provisioning, and so on. We see this here in the profiler component, the guest component, the posture component, the authentication, and the authorization piece. So that's what they're referencing here in the policy elements screen here. All right, policies are going to be built based on different policy elements. So we have dictionaries that are pre-built, and we can also add information to a dictionary which defines elements that we're going to reference as part of our authentication or authorization. We have our match conditions based on those conditions that I mentioned before, simple match conditions or compound match conditions, where we're comparing input elements to elements in the dictionary and then coming up with an output process based on that. And then we have the results, right? Policies use policy elements as our building blocks. ISE defines three different types of policy elements, like I said, dictionaries, conditions, and results. Dictionaries are basically attributes that are available for use within our conditions. It's kind of like a reference, a cross-reference, and we would want to make sure that all of the attributes that we want to match against are contained within this dictionary. All right? Conditions are going to specify a set of requirements that indicate the context, right? And then the rules define the actions that ISE is going to take when the conditions of a particular policy get met, right? So if condition, then do this. And then the dictionary is referenced from the conditions and the result. So in this particular example, right, we're going to allow the authentication protocol. We're going to authenticate against a database. We're going to apply an authorization profile, classify the input, check the posture of the input, and install the NAC agent or the AnyConnect agent for profiling. All right, this is just an example of a set of conditions that might be met. All right, so let's take a look at an example. This screen shows several different snippets. An example of how the policy elements, like dictionaries, conditions, and results, get put together to define the overall policy. This policy and the elements that are used in the policy are basically predefined in ISE, and they're used by default after the ISE platform gets installed. So we're not seeing any custom ones in this particular case. The authentication policy is called MAB, M-A-B. That's what we see right here. The policy name is MAB. All right. The policy references two conditions, wired or wireless MAB. All right, we see that there. The wired MAB condition is also shown here. It uses two values defined in the Radius dictionary. All right, so here's our wired MAB policy, and we can see two values that are referenced from the Radius dictionary. The Radius dictionary is also shown right here. We can see that reference there. The wired MAB condition uses two attributes from this dictionary. One is called service type, and the other is called NAS port type. And that's probably the challenge in dealing with ISE the first time, The architecture is fairly straightforward, but understanding how to interpret the elements is what can be somewhat difficult, right? And I think, Andy, you can probably attest to this. It's really a matter of understanding what these elements represent. Like, for example, what is a radius service type? What is a NAS port type, and so on. And so that takes a little bit of getting used to when you're dealing with radius for the first time. There are some documents on Cisco.com that can actually go through and identify some of the common dictionary elements that we see in ISE, but it will take a little bit of research, and we don't have enough time in this class, unfortunately, to go over every aspect of every element that would be contained within the ISE platform itself. All right. All right, so we have wired map condition, again, matching service type and NAS port type. This basically requires, the conditions themselves requires that the service type to be call check and the NAS port type to be Ethernet. All right, so we understand what NAS port type of Ethernet means. It's a wired client, so it's going to come in through a twisted pair Ethernet port, and then the call type, service type is going to be call check. The wireless map condition, which isn't shown on this screen here, would be similar, right? Service type would be call check, but the NAS type, port type would be wireless, most likely 802.11. But there are other conditions that we can match against in this particular case. All right. If we were looking at 802.1x, there would be different conditions that we would match against in 802.1x, right? They differ a little bit differently from MAB because they require a service type of framed and so on, all right? This MAB authentication policy references two different conditions with a logical OR, meaning that one or the other condition needs to be matched, right? There's the OR that we see right here, indicating that we can match one condition or the other condition. If either condition gets matched, the result gets applied, and then this is the result. And we can see that the action is default allowed protocol service, host lookup, allow PAP, ASCII, authentication protocols, and so on. It's a little bit truncated here, so we're not seeing the complete scenario, but this is essentially a rule, right? And a policy example, okay? Now, the default authentication policy that, like I said, in ISE is rules-based, all right? It's rules-based authentication tends to be much more common than simple authentication. I can talk a little bit about the difference between simple and rules-based. In fact, let me go ahead and mention that, even though here. So my battery died on my headset, so I don't know what I was mentioning, but let's go ahead and I want to describe this simple authentication policies. We're not looking at simple authentication policies here, but before we can go into the concept of rules-based authentication policies, I think it's important to understand the concept of a simple authentication, right? We can see that policy types are simple versus rule-based, and then conditions are simple versus complex. So we want to be able to identify really the difference between those two, right? As I mentioned previously, and I'm going to go into it in more detail now, a simple authentication policy allows you to statically define the allowed protocols and the identity source or the identity source sequence that ISE is going to be used for communication, all right? We can't define any condition for simple policies. ISE is going to assume that all conditions are met and uses basically two different ways or determinations for that particular result. We can create a simple policy where we can statically define the allowed protocols and the identity source, or we can create a proxy service-based simple policy where Cisco ISE proxies the request to a policy server to determine which identity source should be used for the authentication process. If the request gets proxied to a different policy server, the protocol negotiation doesn't happen, all right? The policy server is going to basically evaluate the identity source that should be used for the authentication, and then it's going to return a response to the ISE platform based on that response. All right. So here's the basic authentication policy flow. If I'm dealing with a simple authentication, number one, I'm going to identify whether the authentication identity store list has been exhausted, right? If it's been exhausted, the user's not found, and then I'm going to go through a process of identifying what to do based on whether or not the user's not found. If I still have identity sources where I can go and look for users, I'm going to get the next identity store from the list. I'm going to invoke the identity store for authentication. If the process fails, I'm going to go to a process failed option. If the process does not fail, is the user found? If the user's not found, then I'll go to the next identity source, and so on and so on and so on. If the user is found, do I authenticate the user, right? So did the authentication fail or did the authentication pass? Obviously, if the authentication failed, then we're going to simply go to an authentication failed scenario. So three options that we have for failure: either the user's not found, the process failed, meaning that the source is not available, or the authentication failed altogether, okay? The other option that we have is, well, if the authentication passed. If the authentication passed, then we're done, right? We can then decide what we're going to do based on that authentication and move them into the authorization phase. If, for some reason, the user's not found, the process failed, or the authentication failed, then I have to say, based on that failed configuration, do I reject, do I drop, or do I continue? And then again, I'll go through the process of processing that client based on those conditions. Okay. All right. A simple policy can result in one of two things, basically: the authentication passed or the authentication failed. And like I said, I've said a couple times actually already, it could be bad credentials that could cause an authentication to fail. It could be user not found, or it could be that the process failed. All right. Now, when it comes to rule-based authentication, so I just described a simple policy type. Now I'm going to describe the rule-based type. Rule-based authentication policies are built or constructed from attribute-based conditions. These attribute-based conditions help us determine what protocols are allowed, the identity source sequence that's going to be used in the process of authenticating the individual. If you remember, in a simple authentication policy, we could define the allowed protocols and the identity source statically. But in rule-based policies, we can define conditions that allow Cisco ISE to dynamically choose the allowed protocols and the identity sources. So not based on static conditions, but based on actual conditions that we're matching against, and so on. We can actually define even one or more conditions using different attributes from the dictionary, which basically lists the fixed attributes that are supported by the dictionaries, which then can be used in our policy conditions. Cisco ISE allows us to create different types of conditions. You can see what they reference here, simple versus complex. So let's talk about the difference between a simple condition versus a complex condition. All right. We will actually see that a little bit later. I'll mention it a little bit here, but we'll see another slide that talks about simple matching conditions versus compound conditions, what we call complex conditions. All right. If we are doing rule-based policies, we can define multiple rules. We see kind of a list here on this slide. The identity database is selected based on the first rule that matches whatever criteria. All right, so we're specifying use internal endpoints or use internal users and so on. We can also define an identity source sequence that actually references multiple databases. We can define the order that we want ISE to look through those different databases. ISE will then access those databases in that sequence until the authentication succeeds. Unlike traditional AAA, where if a user is found, say for example in the first database, but the authentication fails because of a failed password, then we simply won't move on to the next condition. But in ISE, we don't do that. We continue to move through different identity sources until we can exhaust all those sources or until we can authenticate successfully. All right. All right. There are several different dictionaries. There are system-defined dictionaries that we can reference, as well as radius vendor dictionaries. Radius system dictionaries include things like certificate, radius, device, and so on. The radius vendor dictionaries include airspace, Cisco, Microsoft, network access, and so on. When it comes to the system-defined dictionaries, device could be device type, device location. It could be some sort of custom network device group, software version, model name, and so on. For the radius system-defined dictionaries, you're talking about all the radius attributes. And then for the network access, which falls under the radius vendor dictionaries, you could have things like the authentication method, authentication status, the device IP address, username, was the machine authenticated? If we're doing that user and machine authentication, what's the protocol? Certificate, we can match on anything that's contained in a certificate, issuer, common name, subject, organizational unit, email, country, and so on. All kinds of things, right? And like I said, this is really the challenge when dealing with ISE. It's being able to identify really all of these individual elements that you're going to match against for the authentication. Now, it can be really simple. We can do basic username and device type authentication, or we can get rather complex. So that's the challenge that you run into when you're dealing with these different conditions. All right, so here's an example of a simple condition. The device is the device type equals wireless. This syntax includes an attribute, which is written in the format of dictionary : dictionary dash attribute, and the operand, and then finally the value. So device type equals wireless. That's a simple condition. Very basic, right? Compound conditions and or multiple matching scenarios, right? The certificate serial number equals this, or network access ISE host name equals policy service branch A, and so on. Just an example, again, not really specific. I mean, it is specific, but not something that you would necessarily see in your environment, because this is only specific to the example. It doesn't really have any reference to kind of a general parameters that you might match against. So it really just depends on what you're trying to match against in your own environment. Will depend on how you configure these different conditions. Obviously, the operator, which allows us to combine multiple conditions together, giving us this compound condition, is and or. Those are the options that we have. All right. The procedure in this slide here describes basically how to define rules-based authentication policies in ISE. We're going to use the procedure only in environments where the default authentication policy needs to be tuned. So we're going to define a simple condition, create or tune compound conditions, define the allowed protocols, define a rules-based authentication policy, where we create a new rule, define a rule, or add conditions to an already existing rule, specify the allowed protocols, identify the identity sources, and then finally tuning the default rule. The default rule allows us to define actions that we would take, if no other conditions or no other rules were matched. And these rules are processed from the top down, by the way. So we're trying to process these rules in consecutive order to identify a specific match condition. All right. So define the simple conditions first. If you're going to use them, define your compound conditions, define the allowed protocols, tune or create your authentication policy sets based on selected conditions, choose the allowed protocols, select the identity source, tune the default role, and so on, because that default role is what's going to be used last. All right. So here's an example of how I might create a simple condition. I go under policy, I go under policy elements and conditions. In this particular case, we're creating a simple condition that consists of an attribute, an operator, and some sort of value. We can create simple conditions from inside the policy pages and also as separate policy elements that we can reuse or reference in other policies, if that makes sense. So kind of a nested condition. So access through HQ switch in this case, the attribute is NAS IP address equals 10.10.2.2. So we're saying, okay, if somebody is coming through the HQ switch, this is a condition that we're going to match. We don't know what we're going to do with this condition yet. It's just a condition that we're defining. Does that make sense? All right. It can get, like I said, it can get very complicated when you're dealing with these different conditions. There's lots of documentation on Cisco's website to identify this. All right. One of the things that I hadn't mentioned before is different policy modes that we can operate in as well. If you go under policy, you can see when you go under policy, it's not on this slide here, but if I was to go under policy here, right, I would be able to identify under policy an authentication policy, an authorization policy, a profiling policy, posture policy, and so on. We can see them listed here, right? Authentication, authorization, profiling, posture, and so on. All right. There's two types of policy modes, simple mode and policy set mode. We can choose either to configure authentication or authorization policies. If we change the policy mode, we need to log out and log back into ISE depending on what mode of operation we're going to operate under. So again, simple mode versus policy set mode. Usually we'll do everything under policy set mode. That's typically where we're going to apply. In simple mode, we basically define authentication and authorization policies separately from the policy menu. In policy set mode, we create policy sets and logically group authentication and authorization within that same group. Hopefully when you guys do the lab exercises, you'll see the differences between the simple mode and the policy set mode. All right. I believe that for most cases, you're going to probably deal in the policy set mode. You're probably not going to work too much in the simple authentication policy mode. All right. All right. One other thing I want to mention before we move on from this slide is that if you're going to create some sort of simple authentication policy, that is going to include things like defining the allowed protocol services, configuring simple authentication policies, etc. Before you start that process, though, there's a few things that you have to have in place to be able to successfully configure a simple authentication policy. You have to complete the process of defining all the allowed protocols for network access. You have to configure simple authentication policy using that radius server sequence. So you have to understand how radius is going to be configured in your platform. And if you are going to reference a radius server sequence, you have to have that configured ahead of time as well. All right. You also need to understand, really just the basics of authentication policies in general, right? What are different authentication types? What are different protocols? And what are the different databases that might be included in the process? All right. Also, in order to create policies, you have to be a super admin or at least a system admin in that particular case. All right. So we go to policy, we go to authentication, and then we can start defining our policies, which we'll take a look at in the rest of this chapter here. So that's a simple condition. What we're going to look at is how we can tune conditions as well. In this case here, we can see that a compound condition is created. Compound conditions are always made up of two or more simple conditions, basically. We can create compound conditions as reusable objects from within the policy creation page or from the conditions page itself. We can actually see on this particular slide that it's being constructed from the conditions page. How is that different? I mean, when I say we can create these compound conditions as part of the policy creation page, what am I referencing? You guys understand what I'm saying? It means that I can essentially, go ahead, Andy or Mike.
I think so.
Okay. So you can do predefined conditions which haven't been referenced by a policy yet, or you can go directly under the authentication screen and you can start to create your policies. You can go and create your policies directly in that policy creation section, right? I mean, defining it as part of the authentication policy. All right.
In the new version of ISE, they don't have they don't have simple and compound conditions.
Right.
They
Everything
have
is
library conditions, smart conditions, and then from there if you look at the editor, because it's basically all smart conditions, and then it decides for you whether you want a simple or compound condition.
I mean, they still exist. The creation is done a little bit differently, right? They don't allow you to pick individually smart or compound, right? It determines it for you, is what you're basically saying. Okay. Compound conditions, obviously we already mentioned this. They they actually are comprised of multiple expressions using an operator and or. And then we can use single operators within that compound condition, all right? In fact, it's all and or it's all or. You can't actually mix your conditions, and or ors. If you have complex rule sets, you can achieve a mixing of and ors by nesting different compound conditions within a hierarchy within the actual rule set. A lower level compound condition could use one of these operators, and then a higher level condition could use a different operator. All right? Nested rule sets, kind of difficult to read, kind of difficult to troubleshoot, not really recommended. This particular example specifically illustrates a predefined compound condition. We have a wired 802.1x client consisting of two individual conditions that have to be combined together using the AND expression. We see that listed right here, actually right here, right? That's the AND operator used to match 802.1x access requests from wired switches. The first condition checks the service type, make sure it's equal to framed, and then the second condition matches NAS port type, which is equal to Ethernet in this particular case. Descriptions are actually pretty important, obviously. It says here a condition to match 802.1x based authentication requests from Cisco Catalyst switches. All right. In ISE, you also have the option of using a built-in allowed protocol set, or you can create a custom list of allowed authentication protocols. If you go to Policy, Policy Elements, Results, Authentication, Allowed Protocols, Services menu, you can see all the different protocols that are allowed based on default network access. And you could create additional service lists if you wanted to. You don't have to use the default network access service list. You could create a custom service list if you wanted to as well. Then we can identify which protocols are allowed, or the protocol set that's allowed, and basically referenced from our authentication policy rules. Now, one of the other options that we have is to tune existing rules. We can insert new rows above rules or below rules. We can duplicate a rule. We can delete rules. And again, we have two built-in rules by default, MAC authentication bypass and .1x, and then the default rule that always exists at the end of the list, which you can tune, but you can't get rid of it, right? The default rule is always going to exist. We can view the default rule-based authentication policy by selecting the rule-based radio button on the authentication page. You can see the rows that get displayed on the page basically describe all the rules that consists of our policy, and these rules are processed in order from the top down. All right. There's two built-in rules, like I said, MAB and .1x, and then the default rule at the end. The first two rules check for conditions combining the OR operator, right? The MAB rule checks to see if the compound condition is wired or wireless. And then ISE verifies if the access attempt is made using a permitted protocol, and then it attempts to authenticate the client against an internal endpoint database. So you can see all the aspects of that particular rule there. All right. Wired or wireless MAB or wired MAB or wireless MAB using the default network access using the internal endpoints database. All right. We can modify rules, we can duplicate them, we can delete them, we can insert new rules, we can change the position of the rules, and so on. We can insert above, insert below, duplicate above, duplicate below, delete, lots of options. All right. When you add a rule to the rules-based policy, you have to provide its name, you have to identify one or more conditions, and then you have to choose the required or allowed protocol services in the identity source. It doesn't always have to be default network access. You can create custom service lists to include only protocols for specific endpoints or clients. Although I have found that the default network access service list is just fine. Just simply identify what protocols you want to allow on that service. All right. All right, so this example shows us the configuration of conditions in an authentication rule. We click on the plus sign, we select the attribute menu that expands that area, and then we can see options for selecting different conditions, whether it's a simple condition or a compound condition. I mean, essentially, the little icon that shows up here, which doesn't, I don't think you get to see this anymore, but simple condition would be if I only had one rule. As soon as I add a second rule, that becomes a compound condition anyway, because I'm going to add this operator right here. Oops, sorry about that. I'm going to add this operator right here. All right. The next component of authentication or setting up our authentication rules is to allow the protocol service. Here's an example where we use the default network access object, which we can modify. We expand the network access service menu by clicking the little arrow down symbol, and then select the next the network access field. The last element of the authentication rule is the identity source that's going to be used to authenticate the users when a previously defined condition and access protocols get matched. The identity source can be the internal database, it can be an external database, or it can be a source sequence that we've previously configured. The identity source sequence defines, like I said previously, the order of that ISE is going to use to search through different databases to look for specific credentials. The authentication rule can use more than one identity source, or it can use an identity source sequence. You don't see it in this particular diagram, but you can configure an additional set of conditions that need to be matched for a specific identity source to be used for authentication in this case. The conditions that are defined in the section define essentially another layer of conditions, and the authentication rule itself defines one or more parent level conditions. The conditions that are used for selecting the identity sources should be thought of as like a child level condition that get evaluated after a parent level condition is met. So if the authentication has failed, if the user is not found, if the process fails, right? We talked about that when I was on one of the previous slides. I was describing all the different conditions that could result in a failure, and what do I do if